Welcome back, cosmic travelers. We take one last look at our silent, steadfast companion, the Moon. A world of stark beauty and ancient craters, a record of our first bold steps into the universe. But our journey is far from over. Today, we leave the familiar glow of our lunar neighbor behind and set a course for a world that has ignited our imagination for centuries. A world of rusty plains and towering volcanoes. Our next destination, Mars. For our ancestors, Mars was a fiery wanderer in the night sky. Its distinct blood-red hue led the ancient Romans to name it after their god of war. For millennia, it was simply a point of light, a subject of myth, but the invention of the telescope transformed it into a place. In the late 19th century, astronomers like Giovanni Schiaparelli and Percival Lowell sketched what they believed were intricate networks of canals, leading to widespread speculation of a dying civilization, desperately channeling water across a desert planet. This vision of Martian cities and alien life, though mistaken, firmly planted a question in the human mind: are we alone? The dawn of the space age gave us the tools to finally answer that question. In 1965, NASA's Mariner 4 spacecraft flew past Mars, sending back the first close-up images. The pictures were shocking. There were no canals, no cities. Instead, they revealed a cratered, seemingly desolate landscape. Much like our moon, hopes for finding life dwindled. But Mars had not yet revealed all its secrets. In 1971, Mariner 9 became the first probe to orbit another planet. Arriving in a planet-wide dust storm, it waited patiently for the skies to clear. And when they did, the view was breathtaking. Mariner 9 unveiled a world of colossal features. Valles Marineris, a canyon system that would dwarf the Grand Canyon, stretching a quarter of the way around the planet. Olympus Mons, a shield volcano 3 times the height of Mount Everest, the largest in our solar system. Most importantly, it revealed what looked like dried-up riverbeds and ancient deltas. The canals may have been an illusion, but water was real. Mars was not always the cold, dry desert it is today. It once had a thicker atmosphere, and liquid water flowed freely across its surface. Could life have arisen in that ancient, warmer, wetter world? To find out, we had to go there. In 2012, NASA achieved a stunning feat of engineering, landing a 1-ton, car-sized rover named Curiosity in a 96-mile-wide crater called Gale. Curiosity's mission was not to find life itself, but to determine if Mars ever had the right conditions for it. And its discoveries were profound. It found evidence of an ancient flowing stream bed with smooth, rounded pebbles just like those in rivers on Earth. By drilling into rocks that were once mud at the bottom of a lake, it confirmed the presence of all the key chemical ingredients for life. And, perhaps most tantalizingly, Curiosity detected complex organic molecules, the very building blocks of life as we know it, preserved in that 3-billion-year-old mudstone. Building on Curiosity's success, the Perseverance rover landed in 2021 with an even more ambitious goal: to actively search for biosignatures, the definitive signs of past microbial life. Its landing site, Jezero Crater, was carefully chosen. It was once a vast lake, fed by a flowing river delta, a perfect environment for life to thrive and for its evidence to be preserved. Perseverance immediately confirmed that the crater floor was rich in the same kind of organic molecules Curiosity had found. But recently, it found something even more compelling. In late 2023, while analyzing a rock sample, Perseverance made a discovery that sent ripples through the scientific community. Using its advanced Sherlock instrument, the rover found a high concentration of organic molecules intimately mixed with silica and sulfates. Why is this so significant? On Earth, silica is fantastic at preserving delicate structures, including fossils of ancient microbes, and sulfates can help lock in organic matter. To find this specific combination, the right organic materials, preserved in the right minerals, in a location that was once a watery shoreline, is exactly what you would hope to find if life had once existed there. NASA calls this a potential biosignature. It's not yet definitive proof, Non-biological processes could, perhaps, create a similar signal. The final verdict will have to wait for the precious rock samples Perseverance is collecting to be returned to Earth for analysis in our most advanced labs. But with every drilled rock, with every piece of data sent across the void, we get closer to an answer. The search for life on Mars is more than just a scientific question. It's a search for our own place in the universe. Finding that life, even if it's only ancient, single-celled organisms, would mean that the spark of life is not a miracle unique to our world. It would mean the universe is likely filled with it. Our journey continues, but Mars has shown us that we live in a cosmos far more wondrous and full of possibilities than we ever dared to dream.